Hey guys, welcome back. Hope you all are doing well. This is Mohammad Badruddin back again with another vulnerability module from the Portswigger, and today we are gonna start HTTP request smuggling vulnerability module. So before going to the labs, I just want to give you a brief description about this vulnerability, which is HTTP request smuggling, how this vulnerability arises, how you can exploit it, identify it. So before going to tell you what is HTTP request smuggling, I think it will be better that you understand the infrastructure in which this vulnerability arises. So what happened in an HTTP request smuggling attack? So this is what most important for you to understand before you understand what is HTTP request smuggling attack, because HTTP request smuggling attack can be performed or arises in this scenario. So if you don't know about this scenario, you won't be able to perfectly understand the HTTP request smuggling attacks. So what happened in this cloud era, most of the applications in on premises or whether it's in the cloud, the infrastructure which is very common is like you have one front end server for the rest of the world, and behind it you have one or more backend servers or multiple backend servers. So the front end server will handle the request coming from the users from the outside, and then it interpret those requests and send those requests to the backend servers for the logic or for the business logic to be performed, and get the result, send it to the users. This is the same scenario what you saw in the web cache poisoning attack and in web cache deception attack. So both of those attacks also work on these same scenarios, but this is more important before you understand what is exactly the HTTP request smuggling attack. So if you read this content, today's web applications frequently employ chain of HTTP servers between users and the ultimate application logic. Users send requests to a front-end server like here, and sometimes these are load balancer or reverse proxy, and this server forwards the request to one or more backend servers. Like you see here, there are two users, these are the color of their request, and front end will receive those requests, interpret it, and then send it in a sequence to the backend server. It could be one backend server or different backend servers. Okay, so this type of architecture is increasingly common and in some cases unavoidable in modern cloud-based applications. So when the front end forwards HTTP request to the backend server, it typically sends several requests over the same backend network connection. So the protocol is very simple. HTTP requests are sent one after another, and the receiving server has to determine where one request ends and the next request begins. And this is the point where you find the vulnerability, because you can see there are a lot of requests going to the backend server from the front end server, but once the backend server receives those requests, backend server need to find out where the first request is ended and the second request is started. And this is the point, or this is the exact place where HTTP request smuggling attacks are being performed. Fine. In this situation, it is crucial that the front end and back end system agree about the boundaries between requests. Otherwise, an attacker might be able to send an ambiguous request that gets interpreted differently by the front end server and the back end server. Same like in web cache deception vulnerability, that front end server consider the cache in some different way with different parameters, and the backend server understand or consider the things in a different way. So there is a disagreement between the front end server and the backend server, and this is where the vulnerability arises. So if you already solved the web cache deception vulnerability, so you have some idea about that architecture, what we are talking about here. Fine. So let's see, I'm going to this part later, but now I think I briefly describe about the architecture. Now we will go to this part. Okay, so here first of all we will understand what is HTTP request smuggling. So HTTP request smuggling is a technique of interfering with the way a website processes sequences of HTTP requests that are received from one or more users. So request smuggling vulnerabilities are often critical in nature, allowing an attacker to bypass security controls, gain unauthorized access to sensitive data, and directly compromise other application users. So request smuggling is primarily associated with HTTP 1. This is the most important thing because you can perform the HTTP request smuggling attack with HTTP 1.1, mostly HTTP 1 version request. Okay. However, website that supports HTTP 2 may be vulnerable depending on their backend architecture. Fine. So let's see this picture. So here you can see he's an attacker who crafted a request like this and sent it to the front-end server. Now, what basically this guy did, he created one request, okay, and within that same request, he created another request. Fine. So this is completely one request, but inside, once the backend server will interpret this request, he will say, okay, this is the first request and it's ended here. Now from here, this is the second request. So what happened when it sent this request to the front-end server will send this request to the backend server in the sequence with another request. But once the backend server try to interpret this request, backend server will see, okay, this section is the first request and this section is the second request. Now you see what this attacker did. Maybe the /admin functionality is not allowed for any other user, or maybe this is not allowed for some, or maybe this is only allowed for some specific IP addresses or something, or there are some kind of restriction or access control policy with the admin panel. So the second request is being executed by the backend server and send the reply to the attacker, or maybe he does not need the reply, just this request need to be executed on the backend server. Fine. So this is how it works. And the two most important components here for this vulnerability or for this attack to be performed are content length and transfer encoding. So sometimes you will see this attack like content length and transfer encoding attack, like CL.TE attacks, and sometimes you will find it as TE.CL attacks. Okay, so we will see that in a minute. Now we back to this point. Okay, now here we see the same scenario what we saw here. Now you just memorize this picture into your mind, that the attacker created another HTTP request within one request. Fine. And then send it to the backend server sees, okay, one request ends here and the other request is started from here. Okay, and we will also see the meaning of content length and transfer encoding in a bit moment. So we come up to here. Now in this situation, it is crucial that the front end and back end systems agree about the boundaries between requests. So that's what we saw. Now the thing here is, let's say this is some genuine another user and this is the attacker who created a request, and within that request he created one malicious request. Okay, so both of these requests are being sent to the front end server send it in the sequence. Okay, now you see when this request is received by the backend server, what backend server will did, backend server see, okay, this is one request and this is another request. Okay, and this request basically comes with this request within this request, but the backend server interpret this request as a separate request and merge it with another request. Fine. So that's how you can understand it. And this is a very good picturization of HTTP request smuggling attack for you to understand. Now here the attacker causes part of their front-end request to be interpreted by the backend server as the start of the next request. Fine. So backend server, you see this half blue part is being considered as one request, and this second orange part is being considered as the second request or start of the other request. So it is effectively prepended to the next request and so can interfere with the way the application processes the request. And this is a request smuggling attack, and it can have devastating results. Fine. So as we saw in the first picture, that we can access some different endpoints through the backend. So of course this is devastating. Now, how do HTTP request smuggling vulnerability arises? So I will try to explain it as simple as possible, and I will take the language of these content because this content is really very simple to understand this concept. Okay, so I'm not going here and there, and I will take the content and I will try to explain it. So here, most HTTP request smuggling vulnerability arises because the HTTP version 1 specification provides two different ways to specify where a request ends. And that's what I told you just before few minutes, that the HTTP request smuggling attack can be possible because of these two components or these two HTTP request headers. The first one is content length header and the second one is transfer encoding. Now the content length header is straightforward and we all know about it as well as the name is concerned, content length. That means how many bytes are there in the message body. So it specifies the length of the message body in bytes. So let's say here the content length is 11. So how it defines the content length? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the content length which is defined here. Fine. Now transfer encoding is maybe a bit trickier for you to understand, but easy. So transfer encoding header can be used to specify that the message body uses chunked encoding. Okay, the message body, this is the most important part. This line you have to remember about transfer encoding, that the message body uses chunk encoding. This is how we specify through the transfer encoding. So this means that the message body contains one or more chunks of data. Each chunk consists of chunk size in bytes expressed in hexadecimal and followed by a new line. Followed by the chunk content, the message is terminated with a chunk of size 0. So whenever you see chunk size 0, that means the message is terminated. So there are three key points you need to remember. Transfer encoding is used for chunk encoding, okay, in the message body, and also there is one that message body contains one or more chunk data. This is also important, and the chunk size in bytes. Fine. And followed by a new line always whenever it is defined. And also if the chunk size is 0, that means the message is terminated. Fine. Now you see this example. So here you can see this is a post request content type. So in these both of these requests, they just mention one HTTP request header here, which is content length, to just make you understand. And here also they just define transfer encoding. They did not put here content length so that you can understand it better. So now you can see, as the HTTP 1 specification provides two different methods for specifying the length of HTTP messages, it is possible for a single message to use both methods at once. As I mentioned here, that these are the examples to make you understand the things about the chunk encoding and the content length, but you can use both of these request header in a single HTTP request. So it is possible to use both of these methods at once in a single message. So we need to use that in such a way that they conflict each other. Now the specification attempts to prevent this problem by stating that if both content length and transfer encoding headers are present, then the content length header should be ignored. Okay, this might be sufficient to provide ambiguity when only a single server is in play, but not when two or more servers change together. Now in this situation, what will happen if if both of these header are being used in a single request, at that instant, if there is only one server which is handling the request, okay, so it will take the content length header and the other one is being avoided. But if a series of or chain of servers are being handling the same request, like front end and back end server, so maybe the front end server will take the content length header and process the content length header, but the back end server will process transfer encoding. Similarly, it could possible that the front end server will process the transfer encoding or will read the transfer encoding and leave the content length header, and backend server will consider the content length header. Fine. So here there are 2 points. Some servers do not process or do not support the transfer encoding header in request, and some servers do not support the transfer encoding header, can be induced not to process it if the header is obfuscated in some ways. Okay. Now, if the front end server and back end server behave differently in relation to transfer encoding or possibly obfuscated transfer encoding header, they might disagree about the boundaries between successive requests and leading to the request smuggling vulnerabilities. So sometimes you will also see TE.CL vulnerability. As I mentioned before, you will see content length transfer encoding content length, yani CL.TE and TE.CL vulnerabilities, but you will also see TE.CL vulnerabilities. And this is the case what I just explained here. As I mentioned before, the front end and back end server behave differently in relation to possibly obfuscated or transfer encoding header, because they might disagree about the boundaries between successive requests. Okay, so sometimes you will see TE.CL vulnerabilities also. Okay, so how this CL.TE vulnerability works, we will see that in a minute. So let's see. So here they define CL.TE first. Now CL.TE, this is in sequence. So CL is the front, this is gonna be the front end and this is gonna be the back end. So CL.TE, in CL.TE, content length is being processed by the front end server and transfer encoding will be processed by the backend server. If you see TE.CL, that means transfer encoding is being processed by the front end server and content length will be processed on the backend server. So this is just the naming convention to make your life a bit easier. Okay, so here is the front end server uses the content length header and the backend server uses the transfer encoding header, and we can perform a simple HTTP smuggling attack as follows. Now they are just defining here or explaining here the architect where the front end server will handle the content length and the backend server will handle the transfer encoding, and that's why CL comes first and TE comes later. Now we can perform a simple HTTP. Fine. So basically a threat actor can create this request, okay, where the front end server will see this content length. It will read the content length, although this header also exists in the same request, but the front end server will ignore this and just see this one. So front end server will process this content length but ignore this transfer encoding and send the request to the backend server. Backend server will see, okay, transfer encoding is chunked, and as you saw before, as I mentioned before, if the chunk size is 0, that means the first request ends here and the second request will start from the from this. Okay, so instead of this smuggled word, an attacker could write a complete new request, okay, so that on the backend server it will be considered new request and will be processed at separate request. Now we will see the description. The front end server processes the content length header and determines that the request body is 13 bytes long up to the end of smuggled. Fine, up to here, because this is what 13 lines or 13 bytes. Now this request is forwarded to the backend server. So first of all, you need to make sure that the front end server will consider this complete request, because if front end server will not consider it complete request, then maybe this part will not be sent to the backend server. Okay, so first of all, you need to make sure your complete request need to be sent to the backend server. Only then, once the backend server will see the request, because transfer encoding header is there, and it will see, okay, chunk size is having 0 length. That means the request is terminated at that point. Now the following bytes, which is smuggled, are left unprocessed, and the backend server will treat these as being the start of the next request in the sequence. Fine. So this is how it works. And there is also a second vulnerability, which is TE.CL. So this is TE.CL, and we will cover this as we go forward, and within the labs I will explain it. Fine. I already described CL.TE, so I will first start with the CL.TE lab. Okay, that's it for this video. I'm gonna see you in the next video with the lab. Bye.